Let's take a look at inverse functions. We have here, suppose y is equal to f of x is a one-to-one function. The correspondence from the range of f to the domain of f, our function here, is called the inverse function of f. The notation we're going to use to represent inverse functions would be f, and we have what we would say -1, but we would read this as f inverse. So what this means, it says if y is equal to f of x is a one-to-one function, then f has an inverse function. X is equal to f inverse of y. An easier way to look at this is an inverse operation is the quantity which cancels out a given quantity. So how are we going to determine when two functions are inverses of each other? Well, what we're going to do is compose the functions, meaning that we're going to plug x into one function, then plug that function into the inverse function, and then simplify. Meaning, when we solve this, we're going to solve it algebraically. And the way that we're going to determine if one function is an inverse of the other, here again, we're going to compose those functions, and as we compose those functions, it's going to equal to x. So we have g of g inverse of x, or g inverse of x, g inverse of g of x is equal to x. So that's a lot to say. Let's work this out to determine if g of x equals to x cubed plus 2, if its inverse is g inverse of x is equal to the cube root of x minus 2. So we're going to compose those functions. So let's look at g of g inverse of x. So what we're going to do, we're going to work the innermost function first. So we're going to take the cube root of x minus 3 and we're going to substitute it into the other function for x. So we have here the cube root of x minus 2 cubed plus 2. Now remember, what negates a cube root is the power of 3, or what negates the power of 3 is the cube root. So that's going to cancel out. We have x minus 2 plus 2, and we know -2 plus 2, that's going to cancel out. We have x. So right now, g of g inverse of x, to show if these two functions are inverses of each other, we would say yes. Now, let's do the opposite. We are going to work the opposite way. G inverse of x, g inverse of g of x, let me say that over again, equals 2. Now this time, working with the innermost function first, our g of x function, we're going to substitute this x cubed plus 2, we're going to substitute it into the other function for x. So we have here the cube root of, where we see x here, we have x cubed plus 2 minus 2. And working under the radical sign, those 2's are going to cancel out, and we're left with x cubed. And the cube root of x cubed, the exponent of 3, and the cube root is going to cancel out. We have x. So to determine if two functions are inverses of each other, we're going to compose those functions. And then if it's equal to x, then they are inverse functions of each other. Let's look at the next example. It says the graph shown is that of a one-to-one function. Draw the graph of its inverse. So if we go back to our notes, what we have at the beginning, it says here we have a theorem. The graph of a one-to-one function, f, and the graph of its inverse function, f inverse, are symmetric with respect to the line y equals to x. So we need that theorem to help us to determine if this graph is going, well, it's already saying that it's one-to-one, but when we draw the y equals to x, that's our reflection line, then it's saying that our function, our original graph, and then its inverse that we're going to draw, they're going to have symmetry. So let's identify the points on this graph here of our original function. We'll just call it f of x. So we have here -1, 0. We have 0, 3. And we have 1, 4. So if we want to find its inverse, all we're going to do is reverse the coordinates. So we have 0, -1, 3, 0, and we have 4, 1. And let's plot those. 0, -1. We have 3, 0. And we have 4, 4, 1. Okay. So we can connect. Now, how do I know if these two graphs that we have here, if they are symmetric? You have what's called a y equals 2 line. It is the reflection line. Where what you're saying, whatever x is, y is the same thing. Reflection line. So if x is 1, y is 1. If x is 2, y is 2. If x is -1, y is -1. So if x is 0, y is 0. So this would be our reflection line that I'm drawing here. And then if we fold at the reflection line, then what this is saying, that -1, 0 is going to touch 0, 1. 0, 3 is going to touch 3, 0. 1, 4 is going to touch 4, 1. Then we would say that they're symmetric to each other.